So, hello and welcome to GeeksforGeeks. Uh, Before starting, can anyone from the chat can acknowledge if I'm perfectly audible and my screen is visible or not? So, can anyone acknowledge if I'm audible or not? Yeah, yeah. So today we are going to discuss these problems, which are like the editorial for this ongoing interview series, which is like happen every week at 8 p.m. each and every week. So you can join. And today's session is like was supposed to taken by Dhananjay Mishra, but due to some medical emergency, he is not able to take this session. That's why I'm taking this session. So before starting, it will be great if anyone in the chat can acknowledge if my voice is audible to you and my screen is visible. Yeah. Thank you, Vishali. Okay, so I think I'm audible. Thank you, Nishan. So I think we should begin with today's problem. Thank, uh, Thank you all for acknowledging. So let's see the first problem for today. It is the name of the problem is valid string. So this is the problem. Let's read the problem first. Then we'll discuss about that. So in this problem, we are given a function compress, and the compression mechanism can delete arbitrarily many characters, maybe zero, and replace them with the deleted character count. Right. So we are given two strings s and t, where s is a normal string and t is the compressed string. So we have to determine if that string t is a valid compression of string s or not. So the objective of this problem is we are given two strings s and t, and we have to determine, like we have to check if the string t is a valid compression of string s or not, right? So let us understand it using the given test case, like some examples. Just a moment, show my whiteboard. Right. So suppose in the test case we are given like the original string is, so suppose the original string is geeks for geeks, and the compressed string is given G7G3S, and the compressed string is given G7G3S. So this is the sample input. Let us understand that what is happening uh, in this input. So this is our input string and this is our compressed string, right? So we have to check if this is a valid compressed string for that string or not. So in the compression, what is the compression mechanism as explained in the problem? It is for compressing the string, what are we doing? We are just taking, like, removing some of the characters. For example, suppose I am removing these four characters, and if I remove these four characters from the string, I'll just replace it by the count of these characters. So since if I remove these four characters, then I'll replace these four characters with 4, and the rest of the string will be as it is. So this is the compression algorithm, right? So now let us check the given input. Let's try to figure out what is happening. So here, since here 7 is written, so what this means is we are just after G, we are just deleting the 7 characters. What are these 7 characters? Let's check. So E is the first character, this E is second, K is third, S is 4, F is 5, O is 6, and R is 7. So we are just erasing these 7 characters and replacing it with S, right? So for checking it, what we have to do, we will just match these. If these, like, if these individual things matches, then we'll conclude that this is a valid compression. So here G matches G. Now these 7 will remove these 7 characters from the original string, right? And after that, here is G, this G matches this G, and after that we are having here 3. So what we have to do is we have to remove the next 3 characters. So we'll remove these characters, right? So this will denote these 3, and after that there is a S, right? So here we can see that all the characters matches, hence we can conclude that it is a valid compression, right? So let's take another example for better understanding. So suppose if I am given a string like this: A B C D E F G H, right? And like this is the original string, and suppose I am having the compressed string like 8. So can anyone from the chat tell me if it is a valid compression for this string or not? Anyone from the chat can answer this. So in the input, like the input string is A B C D E F G H, right? And the compressed string is given 8. So is this a valid or not? Yes, Aditya is answering it's valid, which is right. It is valid. So what are we doing in this is we are just taking all the characters present in the string, and we are just removing all the characters and replacing it with the number of characters. So hence we can say that it is a valid string, right? So these are the valid strings. Yes, Mukta, you are also right. Now let's take one more example. Suppose I am having the same string. Yes, Shashank, Urshali, you all are right. It was a valid string. Now suppose I am having this string, and I'm writing the compressed string for it as 1 3 F G H. So can anyone tell me if this is a valid string or not? My question to the chat is this is a valid compression or it is an invalid compression? Can anyone from the chat answer for this these given string? So this is A B C D E F G H, and I am writing here A 3 F G H. Yes, Chirag and Aditya are answering invalid, which is right. So let's see why this is an invalid compression. So here, idea is simple. We will just start matching these characters. A matches A. Now here is C. So we'll just ignore the three characters, like the three further characters, and after that we'll try to match these two characters, and we see that these characters are not same. Hence, we can say that this is an invalid compression, right? So now I think the question will be clear. We just have to check whether it is a valid or not. And if it is valid, then we will return 1. Otherwise, we will return 0. So this is the question. So now let us see some approaches, and let's figure out how can we come up to the solution, right? Yes, all the people who are answering no, Sai, Amy, Mukhtar, all are correct. It is an invalid string, invalid compression. So let's see how can we the first approach. How can we approach this problem? So the first is the very basic approach, which is just the first approach which can come into the mind. So we have to check if this T is a compressed version of S or not. So since T is the compressed version, so let's try to uh, decompress it. Basically, we let's try to form the full string from out of this string. So what we can do is we can just like suppose this is A, so we can write this A as it is. After that, there is 3 written. So for that, what we can do is we can just write any random character there, like we can say the wildcard character, which can be any alphabet. We are not interested in what alphabet is that, right? So we'll just write three any random characters, and after that we'll write F, G, and H, right? And the input string, then we will write the input string, which is A, B, C, D, E, F, G, and H, right? And then what we can do is we can just compare each and every character. So if there is a mismatch other than these wildcard characters, say random characters, so then like if there is any mismatch other than these characters, then we can say that it is a invalid invalid compression, right? So here these E and F mismatches, hence we are concluding that it is an invalid compression. But if suppose I was given like I write the compression like A4FGH for the same string, then we can write it like A star 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 F G H, and the original string was A B C D E F G H. Now we can see that here, apart from these wildcard, like the random characters, all the other characters matches at each index. Hence we can conclude that this is a valid compression, right? So are you getting this idea? So this is the basic approach which we can think of, like, right? This is an easy approach. So we can just, so in this, what are we doing is we are suppose I am having any random any random compressed string like this, and what I can do is I can just take a temporary string in which I can store its bigger version, like the uncompressed version, right? So I can write this string as this, and after that I'll just compare all the characters which are not equal to these wildcard characters to the original string and check if they matches or not, right? So this can be a solution. So here, what are the time complexities for this solution? Can anyone tell me in the chat? Like, what is the time complexity and what will be the space complexity for this solution? What will be the time complexity and what will be the space complexity? Anyone? See, it is we are not. Yes, I can see some answers. So we are not doing much. We are just traversing the string only once, like the given string only once. So if yeah, so here O of n, by O of n, we mean that the sum of these numbers should also not like should be in the range. Like suppose I write here some very big number, so then I have to repeat these wildcard characters many numbers of time, like a very large number of times. So we can just handle this part by comparing these with the length of the original string. As we know that the length of this temp shouldn't exceed the length of the given string. So we can handle that part. So hence the time complexity for this solution will be O of n, and the space complexity for this solution will also equal to O of n, right? So yeah, this can be a solution. We can do it in this way, but we can do a better thing. Like we can do better than that, right? So in the question, we can see that the expected time complexity is O of t, which is O of n basically, and the space complexity is O of 1. So here we have to think of the way to improve this solution so that we are able to improve this space complexity part, right? So we want to change it to O of 1. So uh, what is the problem? Why are we getting this space complexity of O of n? We are getting it because we are storing like we are storing the uncompressed string into another string, right? So in doing that we are getting this extra space complexity. So let's see uh, how can we improve this, right? So for that, let's take another example, right? If anything is not clear, you can ask me in the chat anytime. If there is any doubt, I'll explain. Uh, right. So let us take another example. So let's. I'm just taking this string. Ph. Okay. So I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 characters. And suppose I have the compressed string like A3, E, F, 2, I, J. Right. So suppose this is the given example. Let's now let's try to think a better approach. Right. So what we can do here is, yeah, so if the previous approach is clear to you, then I'm going to discuss a better approach. So suppose I'm having like I'm traversing this. Just a moment. Yeah. Suppose I am traversing this compressed string and I am having a pointer at the beginning of my original string, right? So suppose this pointer is equal to I and this pointer is equal to j, right? So now what will I do is I'll just compare if like first of all, I'll check if it is a alphabet or not, right? Because if it is not alphabet, then this character is not present there. Basically, if it is a number, it means that there are some other characters which are present, but we have erased them. We have, yeah, we have erased them. So if here is like if they're present an alphabet, then we can just compare that alphabet to the original string. So we have to check like these characters should match, right? So this is the condition. So if there is any mismatch like that, then we can just return from there. Like if these characters did not match, then we can return. Now I'll just move here, and here I'll found that there is a number present. So what this number is, what is the meaning of this number? It means that it means that there were three characters present in the original string, right? So this three means that there were three characters present in the original string which are now removed, right? So since they are now removed, then we cannot compare. Like we just have to suppose my pointer is like my pointer is at index 0. Now I move here and I found 3 here. So what this 3 means, that I have erased these three alphabets, right? I have erased these three characters. So I do not have to compare these three characters to my, like, to all the characters which are ahead. So what I have to do is I have to just jump these three characters and move to this index, right? So this is index 0, this is index 1, this is index 2, this is index 3, and this is index 4, right? So when I was at this index 0, I found the match. So I'll just I incremented my j pointer. Now my j pointer is at index 1. Then I found 3 here. So these three characters are of no use to me. Uh, then then what I have to do is I'll just increment j plus equal to 3, because these three are useless to me. Now I encounter 3 here and I jump to here. Now my j points here and my I points here, and then I can compare these two characters, right? So is this thing clear to you? Hi Himanshu. Yeah, hi Himanshu Clarion. So if there is a doubt, if there is any doubt in this thing, you can ask, right? So this is the basic thing. Like this is the only thing which we have to notice here, that if we encounter any number, then in the original string we just have to skip those many numbers, right? So this is the thing. Now let me take another color, right? So now I am pointing to this e and this e, they matches. So I move to the next character, they also matches. So I move to the next character and next character. Now here I again encounter a number, right? So I encounter a number, that means that I have deleted two characters in the original string. So what I have to do is I just have to delete these two characters and jump two, like, two indexes ahead, right? So I'll just make j plus equal to 2, so that I reach here at I, and here also I am at I. So these two characters also matches, and these two characters also matches, right? So this is the approach. And at the end, if all, like, if both the characters, like if both both these pointers reach the end, then I can say that these like this compressed string is the valid compressed string, right? So this is the approach. So if there is any doubt in the approach, you can ask. Otherwise, we'll just see the implementation. Or you want me to take one more example to explain? If it is not clear, I can take one more example. Otherwise, we can just move on to the code. So let's discuss what all the things which we have to edge cases. Okay. So you want one edge case, right? So let me think of an edge case which might be there. Yeah. So I think I should take this case. So for the same example, so suppose I am just having the C G H, and I'm having the compressed string like A, 4, F, and G, right? Okay, Aditya. Just let us see this example. Uh, this is one of the edge case which we have to handle. I think can make error here. So can anyone tell me if this is a valid compressed string or not? Is it a valid? Is it valid or not? So so let's try to figure it out. So we'll point the J pointer here and the I pointer here. Right. Now these two matches. So we'll move here and here. Right. So here it is 4 written. So we'll just skip these 4 characters and move here, and we'll compare it with F. Now these two characters matches. So we move here. So J pointer is here and I pointer is here. Right. Now these two, both of these matches. So now the I pointer reaches the end of the string, right? So this string is finished, correct? But and the interesting thing is we haven't encountered any mismatch until now, right? Because all the characters until now matches, and this string is finished. So since we haven't found any mismatch, then there may be, like, we can make this mistake that we can just say that these two strings are compressed, but we haven't reached the end of, like, this J pointer haven't reached the end of the original string. Hence we can say that this is an invalid compression, right? Yes, you are right, Aditya and Annie. These are not valid. So this may be one of the edge case which might be missed. Another one which I think could be missed is, suppose suppose we are having a very bigger test case, right? Suppose I'm writing geeks for geeks, uh, right, this, right, something like this. This is a bigger string, and I'm writing here, like, the compressed string could be something like geeks 10, and after that something else, right? Anything. I'm not interested in that. Yes, Aditya, this is the mistake, right? You are checking j less than s dot size here. This condition is also valid, right? this, like here, j dot size, what is the value of j dot size? J dot size is equal to 10, right? So you have to check that j is equal to s dot size, right? But you are checking j is less than s dot size. J shouldn't be less than s dot size, it should reach the end, right? So that's why I have taken this example. This j pointer should reach the end of the string, it has to finish this string. Otherwise this is the same. That's why I take this example. So j should be, this is the wrong condition. J should be equal to s dot size. This is the, this should be the actual condition, right? This is the correct condition. And one more thing which might be missed, like suppose the compressed string is given something like this, right? So here we generally traverse the string bit by bit, like we just are interested in the like one index. So when we reach here, we'll just found one, right? And we found one, and what will we do is we just move one step forward, and after that we'll find zero, and we just move zero steps forward. But it will give me the wrong answer, right? Because this 1 and 0 are not the individual entities, it is the 10. So we have to cover this test case also. Aditya saying outside loop it shouldn't be less than s size. Okay, you are taking, like you are talking about the outer loop. Yes, this is, yeah, this condition is correct. This is correct condition that uh, yeah, so this shouldn't be greater than s dot size, that's right. But at the end, when you finish the comparison, this j pointer should point the end of the string. So this is the very important condition which we have to keep in our mind. And the second one is this condition. So if there are like but 2 or 3 digit numbers present in between the string, then we must, like we shouldn't take it as 1 1 and 0. Instead we have to take it as 110. So this is the mistake which we can make during the implementation, right? So is there any other doubt, anyone? Like Aditya have put a very decent point here, right? I really like that. Any other doubt are welcome. So I think we should see the implementation for this code now, right? So this is the function which we are having, right? So uh, I think I should write this code again so that you all are with me while writing the code, right? Pre-written code, I think is not that interesting. Just a moment. Right, so this is the function which we have to implement. We are given the string s, which is the original string, and the string t, which is the compressed string. So I'm just storing the size of t in one variable. It is not best required. So I'll just take 2 pointers. One pointer, the j pointer is representing the original string, and I'll just traverse using the I pointer in the compressed string, right? So now if there is a function is alpha which will check if the current character is an alphabet or not. So I'll just use that. So if my current t of I is an alphabet, then I have to check if t of I is equal to s of j. If it is not equal to s of j, then I'll just return 0, and before that I can just check the bounds, like the j should be less than s dot size, right? Otherwise it can give me a runtime error if j is greater than s dot size, and I am just checking s of j, then it will be the segmentation fault. So I'll just check that, and if there is a mismatch I can just return 0, and if it matches, then I'll just increment my j pointer, which is pointing to the original string, right? So this is the case when this is an I found an alphabet, and if it is not an alphabet, then what I have to do is, I was talking about this thing. I just cannot do it like this. Like, what this will do is it will just give me the one digit, but the number could be more than one digit, right? So I cannot just consider that one digit. I just have to form the whole number. So for forming the whole number, what I can do is I can just use the while loop, and while I am getting the digits, like the numbers, जब तक मतलब while we are getting, we are encountering the digits, until then we can just run a while loop and update the number, like the form the whole number, right? So I can just check while is alpha t of I. I can just store the digit is equal to t of I minus 0. So I hope you all are understanding why I am doing this t of I minus 0. It is because t of I, like since t is a string, so t of I will be a character, and I'll just subtracting the ASCII value of 0 from the characters. So like all the numbers like 1 2 3 4 in characters are stored continuously. So the ASCII value of 0 is I think 48, and the 1 is 49, 2 is 50. So if I subtract 48 from 50, then I'll just get 2. So that's why we have to subtract that, and I'll just form the number. So it will be number into 10 plus the digit, right? Right. So this is the thing, and I have to like since I'm doing the while loop, so I have to keep in mind that this I shouldn't exceed this t dot size, right? It may be the case, like I'm talking about this case. Suppose the compressed string contains like 10 at the end, then in that case we have to handle that condition also. Yes, thank you, Ayush Yadav. It will be not is alpha ti, and okay, so I just have to write I is less than t dot size, and then not is alpha t of I, and I'll do that, and at the end I have to do I minus minus, because this loop will end when I reach a character. So my I has, like my reach the character part, and here I am doing I plus plus. So that's why, like if I skip this I minus minus, then I will just skip that character. So for avoiding that, I am just doing this I minus minus. Right. So now I have formed like I got the number which is present there. So what will I do is I will just do j plus equal to num. So I'll just increment the counter of my the original string, right? So I think this should be it, and after that I have to check that my j pointer should point the end of the original string, which we have discussed in the sample example. So I think this should work fine. Let us see if there is any error or not. Right, so there is a compilation error. Okay, spelling mistake is alpha. Okay, right. I plus plus. Yeah, I have to do I plus plus. Thank you. Thank you, Ayush Yadav. You are really helping me. Yeah, I have to increment. Yeah, it is successful. So let's try to submit it and see if it is perfect code or not. Yes. So it works perfectly. So this is the code, right? So Aditya, if like you can see this code, uh, and you can check yourself why you were getting the wrong answer. We have handled all the edge cases in this code, right? So if there is any doubt in this code, you can ask. Otherwise, we will see the next question, right? So let's see the second question, which is the maximum path from any node, right? So in this problem, the statement is very short. Given a binary tree, the task is to find the maximum path sum. The path may start and end at any node in the tree, right? So we are just given a binary tree, and we are just asked to find the like each node will have some value, and we just have to find the path with the maximum value, which will give us the maximum sum. And the path can start and end at any node, right? So this is the problem. I think this is a pretty standard one. So let's discuss. Let me just clear my whiteboard. The previous question, if there is any doubt, you can ask. Okay, Ayush is asking what I have done after the while loop. Just a moment. Yeah. So you understand why I'm doing this while loop. In this while loop, we are just calculating the number which is like in between strings. There are some numbers present, and that those numbers can be more than those number can be more than one digit. So for that, like if the number is of three digit or four digit or two digit, we just have to do this while loop. And after that while loop, when this like let us discuss when this while loop will end. So this while loop will end either we reach the end of the string, or if we reach a character which is not a number, which is a alphabet, right? So if we reach the number which is an alphabet, we will come out of that loop. Now we are on an alphabet, right? And after that, like after this loop will end, we will do this I plus plus. So we will move away from that alphabet, right? So that alphabet, we are not doing anything with that alphabet. So basically that alphabet will be skipped. So for avoiding the skipping of that one character, we are just doing I minus minus, which means that we are now our pointer points on the last character, which is equal to a number, right? So hence we are doing this I minus minus, and then we got the number, like the total numbers, the total number of characters which are skipped, right? So we will just skip those number from the original strings, original given string, correct? Karthik, there is a need of I minus minus, I have just explained, and I plus plus is there in the while loop, right? So when like we are forming this number and we got this number, after that we'll just add this to our pointer, like the first pointer which is pointing to the original string. So in the in this variable num, we are just storing the total number of characters which we have to skip, and by adding that to the j pointer, we are just skipping those numbers, right? So this is the thing, right? So these part we have discussed in deep in the example, and after that we just have to check that the pointer should reach the end. If the pointer haven't reached the end of the string, then we cannot conclude that we found the whole string, right? So if that j pointer reaches the end of the string, then we can conclude that we like the both strings are equivalent. The t is compressed version of s, right? So this is the thing. So now I guess we should see the second problem. Right. So in the second problem, we are given a binary tree and we have to find the maximum sum path, like the sum of the. We have to find the path between any two node, and we have to return the maximum value, like the maximum value of the path. Right. So uh, let's take the example. Like let us take sample. Like let's first take the sample example itself. So in that there are this kind of tree. So right. So this is the tree given, and let's see the values. What are the values? That is 10 to minus 20. It's 10 minus 25, 21, 3, and 4. So suppose this is a tree. This is a binary tree which is given, and we have to find the path with the maximum sum. So here we have to notice that there are negative values also present. So we have to keep that in our mind, right? So let's just see. Uh, let's take any two arbitrary node and trace the path between them. So suppose I am just taking this as node 1 and this node as node 2. So let's trace the path. So the path between them is from this to this and this to this. So what is the sum of this path? It is equal to 10 plus minus 25 plus 3, which is equal to minus 12, right? So this is obviously is not the optimal answer, right? Now let's take another path. Let's see. Now let's consider this path from 10 to 2 and 2 to 20, right? So what will be the value of this path? It will be equal to 10 plus 2 plus 20, which is equal to 32, right? Now we can say like that we can choose any two nodes and we can just trace the path between them and see and compare all. Like we have to take the maximum of all these paths. So here we can see that 32 will be the maximum value which we can get, right? So this is the question, right? So what can be the approach for that? So let's discuss the approach. So like these kind of questions are the standard, like this is the standard, this will be the standard approach for all the questions of these types. So for these kind of questions we just have to like subtract the problems into the parts, right? So how can we do that? So suppose we are given this whole tree. So how can we get the answer? Like this tree, for this tree we are just having these two childs. This is the left child and this is the right child, right? So we can just solve the problem for this part individually and this part individually, right? So this should be the idea. And so for solving this we can solve this part and this part, right? And for this part and this part, and the answer for these two like the children will be combined to get the answer for the parent node, right? So this is the general approach how to think for the solution in these kind of problems, right? So let us see how can we do that. So once again let me draw one tree, right? So suppose this is the tree, and yeah, so for finding the maximum path, so this is the root, this is the root for my tree, right? So suppose I am at one leaf node. Currently I am at one leaf node. So what will be my answer? Like suppose I am just given this much of tree, right? This is my whole tree. So for this what will be the answer? The answer will be the value stored in this tree, this node, right? So suppose x is stored in this node, so answer will be equal to x, right? So suppose this is the whole answer, so I'll just return this answer from here, right? Correct. Now same thing I'll do for this, right? So if suppose here is y and I am returning y here, right? So suppose I am at this node and I will have these two values with me, right? This is the left child and this is the right child. So for this node, uh, what all information I am having? I am having the value from the left child, which I am denoting as L value, and the value from the right child, which I am denoting as the right value, right? So what will be the maximum, like what will be the maximum of the what will be the value of the maximum path? The value of maximum path, like for each node I have to consider that node, of course, like for sure. Like if I am considering calculating the answer for this current node, then I'll assume that I am like this node is one of the end, like I am considering this node in my path, right? So if I am suppose at this node, then what is the meaning of that? The meaning of that is this node is in the path of my final answer, right? So I have to take this node, then what will be the answer, right? So this thing which we will calculate in each call basically. So suppose I am at this node, then what are the possible paths which I can have? So one of the possible path is this, right? Another possible path will be this, and one more possible path will be equal to this, right? So what is the difference between these three paths, right? So in this path which is marked by red color, in the red and green path, in both of these path, this node acts as the edge node. By edge I means one of the end points, like this node is the end point of the path, right? And the path which is marked by the pink color, in that it is in the middle of the path, right? So for each node there are only three possibilities, right? So what are these three possibilities? It is, suppose I am at this node, so the three possibilities will be equal to, the path can look something like this, which means that it is from its left parent, like left child. Another possibility is, just a moment. Another possibility is it may be from its right children, like right child. right? And the third possibility will be, it may be from, like it is not the endpoint, but it is in the middle from some path which is like this, right? So these three are the possibilities at each node. Understood? I can have path, like I can have the maximum value from the left child, I can have the maximum value from the right child, or I can have the maximum value from both childs combined. And in that case, this node will be in the middle of the path. And both in these two cases, the node is at the, like one of the edge, one of the endpoint, right? So these are the two possibilities which I am having. So now what I just have to do is, now I just have to calculate this L value. I'll just calculate this L value. Then I'll just calculate this R value, right? I'm just having some value at that node. So what will be my answer? My answer can be equal to the L value plus value. This is a possibility. Or the R value plus value, right? This is a possibility. Or it can be L value plus R value plus value. These are the three possibilities. But yes, Aditya, we will discuss exactly. We are going to discuss that exact point. So, what is the difference between, like uh, like I have categorized my path into these parts, in which I have said that these two paths are similar, because in these paths this node is acting as one of the edge, and this path is different because in this it is not acting as a, it is in the middle of the path. So now we will see what is the difference between, like how these things matter, right? So let us understand it better. I'll just take one example. There was, so let me just quickly take one simple tree, right? So suppose I'm calculating the answer for this node, right? So suppose I'm at this node, then what are the values I'm having? I'm having the L value, and I am having the R value, which is basically the maximum value for these two nodes, like these two childs. So if the value answer for this node I am calculating as R value plus value, in this node value is stored. If I am considering this as my path, so my path looks something like this. I'm taking L value and this value. Now what is this? What does this mean? There is a scope that I can just add this node to this node, right? I can just add this node to this node, which can contribute more. Like there is a possibility that it can contribute more to the final answer, right? But this is only possible if this node is the edge node, right? Are you getting this point? If this node is a, like basically, suppose I am having a path like this, then I can just add another node to these two nodes only. The nodes which are at the edges, I can just add to them, but I cannot add to this node, right? So this is the whole point of categorizing uh, paths into two categories, right? So if it is like, if I am taking the value from the left value and adding the value, like I am considering this path in which this node is acting as an edge node, then there is a scope to add its parent to it, right? To extend that part, there is a possibility. Similarly, if I am taking the value from the L value, then also there is a possibility to, like if I am taking this node, then there is a possibility to extend to that, right? But if I am considering, like suppose here, if I am considering this path, like this whole path, then I cannot, like then this is not allowed, right? Because here the path looks something like this. So in this path, I cannot include this node, right? If I am including this node, so suppose I am from this node, I am moving to this node. I will mark it as 1, 3, 4. So suppose from 1, if I am moving to node 2, then I can just move to one of the nodes. Like I cannot move to both node 3 and 4. I have to choose any one node from them, right? So if I come from 1 to 2, then I can go to 2 to 3 or 2 to 4, right? I have to choose one of them. So this is the difference between these two kinds of nodes. So Aditya, now your question is, what if the optimal answer is not from the root? Yes, it could not be from the root, but in that case it could be like this. We can just consider this node as in some path of, like in between the path, right? Here you can see that this is uh, in the middle of the path, right? It is not on the edge. So in that case, the final answer will not include the root, basically. Correct. So this is the thing. And if and now and I am saying that there is a possibility to add this node. It is also like it is not always necessary to include this node, right? Suppose this contains a very big negative value, then it is optimal not to take it, not to include this node, right? In that case, my like let me quickly take a small example. Suppose this is my root node, right? And here some value 50, here some value 50 is stored, here minus 100 is stored, right? And here 60 is stored, and here 40 is stored, right? Here suppose 10 is stored. So in this case, I am here and I just choose this path. This path will give me 100, which is 40 plus 60. But if like if I'm taking this path, there is a scope to extend this path. So if I try to extend it, I'm encountering minus 100, right? Oh, I just have to take, suppose here is minus 1000, basically very big value. The point is that, so if I try to extend here, if I try to extend here, then what is happening? I am just including a very big negative number in my answer. I'm encountering a very big negative number, and which will contribute negative to my answer, right? So in that case, it is not optimal to extend, like to extend the path, right? What are you saying? If there is a right node to 60, say 1000, you are saying that here it is 1000. Yes, then this is like, this is the obvious thing, na? Suppose then we will not, instead of moving forward, we can just move this way. So in that case, this will be the optimal path, right? So yeah, this thing we have to compare now. For at this node, we'll just compare all the three possibilities. Like we will compare from this possibility, from this possibility, and from the possibility, the third possibility, in which this is the middle node, right? So we will compare all these three possibilities, right? And yes, Aditya was saying it is similar to Galan's. Yeah, you can visualize it like that, because if at any point I am just getting, suppose, yeah, suppose here it is 110. Let me erase that. So suppose here is minus 110 present, right? So I am include taking this path and this path, which is giving me 100 minus 110, which is equal to minus 10. So since I am getting a negative value, then it is not optimal to take this path, right? Because up to that point I am getting a negative value, which will always de decrease my future answer. So I can just take it as 0 and I'll just move forward, right? Because it is just decreasing my answer. So if I encounter a negative value, I will just assume it as 0 and move forward, right? So for 50, I'll just move here 0. I'll not return minus negative value, right? Because it will just degrade my answer, right? So yeah, you can say that it is like the cadence algorithm for finding the maximum subarism, something similar, not exact, right? So yeah, so this is the thing, and we just have to focus on this thing. Like for any node, what will I have? I'm having, like, since it is a binary tree, we will have at most two children, right? From the left children, suppose I will have a left value, and the from right children I will have a right value, right? So what are these values? These are the maximum path sum I can get from whatever present here and whatever present here, right? So this value is the answer for this part, and r value is the answer for right part. Now I have to decide what I have to do. So here is some value present. I can just add this value to val and hope for better answer in the future, or I can just add this value to my val and hope for the better answer in the future, or I can just take it as the middle node and form the path something like this. So whichever is giving me the optimal value, I'll just take the maximum of that and do it accordingly, right? So this is the approach for this, right? So now implementation is also, there is a trick in the implementation for this problem. So in generally what are we given is, we are given the function like this. Suppose we are having a function like this, in which we are just providing the current pointer, and we have to return the maximum value, right? So if the function is given like this, then there is a problem in implementing this thing like this. What is the problem? The problem is we cannot store the answer, like the answer to the value, like since there are three possibilities. So we just can return, like from this node, it is the children of any node, right? uh, just a moment, let me erase this and right. So suppose I am given a function like this, in which I am passing a pointer which is pointing to the current node, and I just have to return the maximum, right? So since I was talking about this nodes, right? So suppose I am currently at this node and I am having some L value and R value, and this node will be the children of some node, right? It may be right child or left child of some other node and its ancestors, right? So I have to pass on the maximum value until the root, right? So I have to return the final answer from this recursive function, right? So what I can do is I can just take the maximum of val plus l value, val plus l val, or val plus r val, right? So whichever is giving me the maximum value I can just return. But the tricky part is, what if I am getting the best answer in this step only? I do not have to go to the ancestors, right? As Aditya mentioned, that there may be a case that the optimal path is not starting from the root, right? So the if we are getting the answer at this point itself, then what is the way to store that answer, right? Because we since uh, this answer in which this node is acting as the middle node, we do not we cannot transfer the answer to the ancestors, right? We can just answer to we can just transfer, like return the answer to the ancestors only in these two cases, when this node is acting as the edge node, right? So what will be the solution for this problem? The solution is, we can just have one variable answer, which, like, you can declare this as a global variable, or you can just pass this variable by reference, right? So you can just pass this variable by reference, or take this variable as a global variable, and you can just store the maximum answer, like all the maximum answer at each step in this variable. Yes, Abhishek Patel, we have to take the max of 3, but the problem was to how to return that. So by storing it in like this in a global or a reference variable, we can just store the maximum answer, and we just return the maximum of these two values, right? We cannot return the maximum of this third value, right? Because this third value, we are getting the answer here itself. We cannot return it to the ancestor because ancestors are not involved in this path, right? So this is the little trick. Otherwise the problem is standard, and the code is also very pretty easy to understand, right? So if there is any doubt you can ask, otherwise we will see the code for this. There is not much in the code, right? Yeah. So this is the code. I'll just I have declared one variable named infinity, which will be storing a very large value, right? Since yeah, so this is the function which is given in the question, which we have to implement, right? In this function they will just pass the root node, and we have to return the maximum answer, right? So what I am doing is, I am just doing the thing trick which I have explained just now. I am just passing this answer variable by reference. So by reference we mean that any changes which we will make uh, in the functions will be permanent, will be reflected to the answer, right? So we'll just pass that, and we'll call this function find max, right? So what are we doing is, we are just traversing the binary tree, like we are calling the left child and the right child recursively. And if I reach, like if my current pointer is equal to null, which means that there is no node present, then I'll just return the 0. This is the base condition for the recursion. Otherwise I'll just, as we discussed, we'll just store the left value and the right value, right? So these are the two variables in which I am storing the left value and right value. Root left is the call to the left child, and root right is the call to the right child, and this answer is the variable in which I will be storing the answer. Understood? Now I'm just having this variable current, in which I am storing the data of the current node, right? So as we discussed, that at each node I am just considering that this node is present in the path. So if I take this node in my path, then what will be the maximum answer? That thing I will be calculating at each call, right? So in this current current variable, I am just storing the value present at that node, right? And these two are the like values which I will get from the left child and the right child, and I'm just taking the max of that, right? So now in current, the value will be stored if I am considering that current node as an edge node, right? This thing we have discussed in very deep. So these two will be that value, and I have to take the maximum of that, because I can just go to any one, like I cannot go to both left and right, right? In a path I have to choose one of them, and obviously I will choose which is giving me the maximum answer. I will choose that side. That's why I'm just taking the max of the both values. Right now, in current, the value is stored if I am taking that current node as an edge node. So I'll just update the answer. Like in answer, I have to calculate the final maximum value. That's why I'll just like, take the max of answer and current. And this is the important part here. Here what I am doing is I am just taking the current value. You can see here that root data is the value present at that node, plus the L value, which is the value from the left child, plus the R value, which is the value from the right child. So this means that my current node is not the edge node, it is between the path, right? So this is that value, and I cannot return that value, because if I am considering that path, then all the ancestors are not included in that part, right? So I will not return that value. So I for this value I'll just take the max, and I will return the value present in the current, right? In the current, since this node is the edge node, then we can add the ancestors in our path. So that is why we are just returning the current value, correct? So this is the code, and at the end, yeah, this is also important thing. uh, Now let me initialize my answer to 0. Will this give me the correct answer if I initialize my answer to 0? Anyone, can anyone tell me from the chat? If I initialize my answer variable to 0, will it give me the correct answer? The answer is no, it will not give me the correct answer. The reason is obvious, because there are negative values present in the binary tree, and if suppose all the values are negative, then my answer should be negative, right? Because I have to choose one node, and if all the nodes are negative, then the final answer should be negative. Yeah, yes, Sahil, you are absolutely right, the answer could be negative. So that's why I have to initialize my answer to a very big negative value, right? So this will be the code. Now let me try to submit this code, and it is accepted. So this is the code. Yes, you are absolutely right, Sahil. It will give 0 even if the max path is negative, correct? So this is the code. If anyone have any doubt regarding the code or the logic, you can ask. Or after, like, if you have the doubt after, like, after this video, you can ask the doubts in the comment section of this video. This will be present on the Geeks for Geeks practice channel, so you can ask there also, I'll reply. And yeah, so we are taking this series interview series every week, like each and every week at the same time, 8 p.m. So for more questions you can join in, right? So I think that should be it for today. I hope you like the questions, I hope you enjoyed the solutions, right? So yeah, that's it for today.